Hello everyone, my name is Kalevani Shankar and my metric number is 225735. I will explain about the introduction, problem statement and also the objectives of the report. Introduction. The motion of a tennis ball on an inclined plane illustrates fundamental physics principle combining rotational and translational motion. Gravity causes the ball to accelerate down the slope, resulting in both linear and angular acceleration. Friction between the ball and the surface ensures rolling rather than sliding, converting potential energy into rotational kinetic energy. This motion is governed by Newton's second laws and rotational dynamics, where the moment of inertia and angular velocity are key. Understanding these dynamics aids in various applications from sports science to mechanical engineering, such as designing tennis courts and automated ball return systems. Moving on to our problem statement, the goal is to understand the dynamics of a rolling ball, specifically how to inclined angle affects its motion. This includes determining friction, torque, and angular acceleration, and analyzing the relationship between the inclined angle, the time taken to roll to the ground, and the resulting velocity and torque. We have two main objectives, where our first objective is friction and rolling without slipping. A tennis ball without slipping when its contact point with the ground momentarily remains still. Static friction, which grips the ball and allows it to move smoothly without slipping. Our second objective is role of torque and angular acceleration. The angular acceleration A depends on torque T at the center of mass of the ball.
Okay, so hi, my name is Michael Manasri. My number is 223802, and today I will tell about methodology in this report. What we use for our method is, first we set up an inclined plane at a known angle, and then we release the ball from a known height at the top of the inclined plane, and then we measure time, and we take 3 times, and then we take the average for the graph. Okay, for the methodology of the inclined plane, we can use torque equation. There is Newton's second law, where T is torque and I is movement inertia and A is angular acceleration. And then we can use torque due to friction, where friction equals to movement inertia and angular acceleration. And then for the next slide, we can use the translational and rotational motion relationship, where the formula is A is angular acceleration and A small is linear acceleration by the radius r. And then we substitute A into the torque equation. Formula Fr equals to I times angular acceleration over r, and we rearrange it. And then for the third is we combining the rotational and translational equation. We can get mg sin theta minus f equals to ma, and there's an explanation about it. And then we combine the equation where we can solving for the angular acceleration. And then we know for the formula for the tennis ball is moment of inertia equals to 2/5 mr squared.
In the previous video, Haikal has been explained about the method that going to be using to find torque. In this slide, I've drawn free body diagram for our tennis ball and what the formulas that I'm gonna use later. I'm going to show the calculation how to get the results from our experiment in torque in the next video slide.
So hi, in the next previous slide, I'm going to show how to get the torque values for the angle of incline 30 degrees. So we can first find the linear acceleration by using this formula. This formula for linear acceleration is the derivation from the rotational motion and the translational motion. So we just substitute all the values. Since the given angle is 30 degrees, we're going to convert into the radian values. So substitute into the formula, we should get pi over 6. Pi over 6 here, sorry. So the final answer is, I've calculated earlier, so I just write it down the final answer. 3.5036 radian per second squared. Next, we can calculate the angular acceleration. By using this formula, angular acceleration equal to linear acceleration divided by radius of the ball. The radius of the ball is 0.0335 meter. So 0.0335 meter. And then this is the linear acceleration. We should get 104.58 radian per second squared. So the last step is to calculate the torque value. So I is the moment of inertia for the solid ball. The formula is 2/5 mr squared times angular acceleration. Substitute the mass of the ball the mass of the ball is 0.056 kilogram, 0.056 kilogram times the radius of the ball 0.0335 squared times the angular acceleration 104.158. So we should get 0.00263 nm. For the angle of incline 45 degrees and 60 degrees, this is the final results. Just use the same steps and make sure your calculator in the radian mode and you will get the final answer as shown here. Thank you.
Hello everyone, my name is Namjisha and my metric number is SA00051.
In the result and discussion, we have chosen 3 different angles of inclined plane to determine how different angle affects the velocity and time taken of ball rolling down the path. From the experiment results and a few attempts, we understand that the higher the angle of inclined plane, the shorter the time taken for the ball to roll to the ground. Therefore, velocity of ball rolling down the plane increase if angle of inclined plane increase.
Hello everyone, my name is Chuani Kampan Anak Perempuan Chuan and my matrix number is 225149. Based on the calculation and the plotted graph, we can conclude that the more the angle of inclined plane, the higher the slope, thus the higher the velocity of ball falling to the ground. Next, we also know that the presence of friction reduces the speed according to the type of surfaces, such that the rougher the surface, the higher the friction. Therefore, it decreases the speed of ball falling to the ground.
The table below shows the value of torque achieved from the calculation explained by Absharina. From the table, we can see that the higher the angle of inclined plane, the higher the value of angular acceleration, thus increase the value of torque.
Through the calculation and graph plotting of the torque against angle of inclined plane, we know that the higher the angle of inclined plane, the higher the angular acceleration, thus torque increases. In conclusion, this dynamic report has successfully achieved its objective by providing a detailed analysis of the subject matter. The dynamic analysis focuses on the effects of time taken for the ball to roll to the ground with different angle of incline, as well as the value of torque. Key finding from the report indicates the importance of dynamic in daily life application. Throughout the report and experiment, we know that there are a lot of factors that need to be considered when building something in daily life. A number of dynamic analysis and calculation is required to ensure the safety and health of everyone.
This report offers us an opportunity to apply the theory and concepts that we learn in class practically to a real-world problem. Studying the dynamics of the rolling ball has not only increased our understanding about this topic, but also provide us with an early experience of engineering challenges before we enter this field. We are grateful for this experience. It is a chance for us to improve our technical skills and provide us with knowledge. Hopefully, we will be able to apply all the knowledge that we gain to projects in our engineering career in the future.